Hi everybody, this is going to be our third video in Unit 8, and here we're going to focus on adding and subtracting rational expressions, which is actually going to be a little more complicated than the multiplying and dividing was. When working with fractions, adding and subtracting is harder because you have to find a common denominator. So that's what we're going to have to do here with the rational expressions. We're going to have to rewrite our expressions so that they have a common denominator that will allow us to combine them by either adding or subtracting. Remember, when we do that with fractions, the only things that add and subtract are the numerators. Once we have a common denominator and we combine our fractions, it just keeps that same common denominator. We don't actually add or subtract anything down there. Once we have actually combined these two together, that's when we can start simplifying the remaining expression by factoring and canceling and all that good stuff. So let's look at an example here where we already start with a common denominator. Y squared minus 9 is the denominator of each expression. So we have addition between these fractions, so we can combine them by adding the numerators together. So when we do that, we would get y squared plus 10y plus 21. And remember, our denominator is going to stay the same. It's going to stay y squared minus 9. Now at this point, we have a single fraction, a single rational expression that we're trying to simplify. So this is where factoring comes into play. At this point, my numerator would factor into y plus 3 times y plus 7. My denominator is a difference of squares that factors into y plus 3 times y minus 3. And then I can cancel out those common binomials and get my final answer, which is y plus 7 over y minus 3. So the only part that's going to be different is we have to actually combine these fractions together first. So let's say we don't have a common denominator. The first thing that we need to do is get a common denominator. So we have a squared and 8a. We need to think about what we could do to make those the same. Okay, the way I like to think about it is this denominator is missing the 8. This denominator is missing the a squared. So we need to think, what would we multiply by to make that happen? Well, this first fraction would need multiplied by 8. So we multiply by 8 over 8 because really that's just 1. And that means that we're not really changing the value. We're just changing the structure of that expression. Our second rational expression needs the a squared. So if we multiply by a, that would turn that into an 8a squared. So the common denominator that we have now is 8a squared for each fraction, for each rational expression. And our numerators now would be 32a and 7a. So now at this point we're subtracting. So we would get 25a over 8a squared, and we could reduce the a's here. So I can't reduce my fraction any, but I could turn this into 25 over 8a. So that's an example with monomials. Okay, but most of the time we're going to have binomials, trinomials, and things like that. So let's look at how we would approach it here. Now, we don't have a common denominator. What I want to point out here, though, is that a lot of times the denominators have more in common than it looks like initially. And what I mean by that is, if you look at the 5k minus 10, really, if I factor a 5 out, that leaves a k minus 2, which is the same as the denominator over here. So what that tells me is that really, to get a common denominator, all I would have to do is multiply this second rational expression by 5 over 5. If I do that, I'm going to get this. K squared plus 16 over 5 times k minus 2 minus 20 over 5 times k minus 2. Now, keep in mind, I'm leaving my denominator in factored form here because I'm going to do that eventually anyway. And once I have a common denominator, it's not like adding or subtracting anything. We're not combining it with the other one. So I would just leave it in factored form and save yourself a step here. Okay, once I have it to the step though, I can go ahead and I can combine by subtracting in this case. So we would get k squared minus 4 over 5 times k minus 2. Okay, I notice that my numerator is a difference of squares. And then we can cancel that common binomial of k minus 2. So our final answer here is k plus 2 over 5. Now, something I want to point out is a lot of people make the mistake at this step here that I just starred. They make the mistake of trying to factor the numerators before they combine the two rational expressions together. That isn't going to get you anywhere. That's just going to confuse you more. The denominators we sometimes factor before we combine to find the similarity in their structure, but you're never going to factor the numerator until after you've combined and gotten to this step here. Okay, so just keep that in mind and be careful with that. So here's another one where the denominators look very different, but looking at my trinomial here, I noticed that this would really factor into y plus 8 times y plus 3. So they have that factor of y plus 8 in common. The one on the left is just missing that y plus 3. So that means I'm going to multiply by y plus 3 in the numerator and the denominator. Now, when I do that, I'm not going to actually multiply anything yet. I'm just going to write it like this. And I'm going to leave my denominator over here in factored form as well. Now, I'm going to combine these numerators together by adding. So let's go ahead and distribute that 7. So we would get 7y plus 3 plus 35. So let's go ahead and just make that a 38. All over, or I'm sorry here, I made a mistake. If I distribute my 7, I really am going to get 7y plus 21. So that's going to make a big difference here. If I do 35 plus 21, I really get 56. And my denominator is still that factored form. So now in my numerator, now that I have it correct, I can factor out a GCF of 7, which leaves me with y plus 8, which is going to be able to cancel with that y plus 8 in the denominator. And we are left with 7 over y plus 3. Oh, I'm saying something and writing something different. There we go. All right, let's take a look at another one here. Okay, I want you to pause the video now that you've seen a few of these, and I want you to try it on your own. All right, so let's get started here. The first expression, I'm going to factor that denominator to see if it has anything in common with this x plus 2. Okay, so if I can really factor that denominator into x plus 2 times x plus 3, that means that I can multiply this rational expression by x plus 3 to get a common denominator. All right, so let's rewrite this. We have x squared minus 5 let's see, plus, so if I have 1 times x plus 3, I really just have x plus 3 All right, so we are adding, so we're going to combine the numerators together now with addition. So we would get x squared plus x minus 2 all over x plus 2 times x plus 3. And now we can try to factor our numerator here. So our numerator would factor into x plus 2 times x minus 1. And you can see now that those x plus 2's are going to cancel out, leaving us with just x minus 1 over x plus 3. Okay, let's see another here. Again, pause and try it on your own. All right, so again, we're looking for similarities between the denominators. I have a difference of squares this time. So I recognize that I need to multiply by m plus 2 over here. So let's see what we have. We have, let's see, I'm going to go ahead and I'm going to factor this numerator as I'm going along, just because I noticed something here that maybe will help make this problem a little bit easier. What I noticed was that my numerator already had a common binomial with the denominator. So what I could do is I could factor this. Notice that these m plus 2's would cancel, which would eliminate the need for me to find a common denominator at all. Okay, but let's assume that you didn't recognize that. Let's just ignore the factoring of the numerator for now and pretend like we didn't recognize that structure there, because you're not always going to catch it and you don't always want to factor the numerator. But if you notice something like that is going to cancel nicely, you're more than welcome to go ahead and do that. So let's just pretend that we didn't see it. Okay, in our denominator we have this still, and the numerator we have this, and then our new rational expression after we multiply would give us 2m plus 4 over our common denominator. So let's go ahead and add and combine the terms in the numerator together. So that would give us m squared plus 7m plus 10 all over this here. So now we can factor our numerator into m plus 2 times m plus 5. Those m plus 2's are going to cancel out. Leaving us with just m plus 5 over m minus 2. So here's one where our denominators have absolutely nothing in common, and it's pretty easy to tell because there's nothing that could multiply the w plus 1 by to make it equal to w minus 7 and vice versa. So this is a case where we have to actually multiply each fraction here. Let me move this a little bit. We have to multiply each of these fractions, these rational expressions, by the part that it's missing, which means this part needs to get multiplied by w plus 1, and this one over here needs to get multiplied by the w minus 7. So if we do that, we're going to end up with 5w minus 35 over w plus 1 times w minus 7. Okay, the order of the factors doesn't matter. plus 8w plus 8 all over w plus 1 times w minus 7. Okay, so now we can add these together. We would get, let's see, 13w minus 43 over this here. And I want you to pause and I want you to think, is there anything that we could do to simplify this further? Is there any way I could factor that numerator? Is there anything that's going to cancel out? Because to me, looking at that, I feel like there should be something else. So I want you to take a moment, pause, and I want you to check and see if there's anything else that you think we might be able to do here. All right, so one thing I noticed was I added some numbers together wrong because I'm just doing great. So let's change this so it actually is correct now. Negative 35 plus 8, not minus 8 like I did, but plus 8 would really give us a minus 27 here. So that might have been why I was a little bit confused. But still, there's nothing that I could factor out of my numerator. There is no GCF other than 1. So this is actually going to be our final answer. Not as clean as I would like it to be, but that's all we can do. Okay, this is going to be our very last one for today. So let's start by looking at our structure again. Let's see, we can factor a GCF of 4 out here, which would leave a P minus 5. And I'm just doing this underneath at the bottom instead of writing it all out at the very beginning to save myself some steps. And let's see, this one over here, I could factor into, let's see, P minus 5 times P minus 3. So they do have something in common. They have these P minus 5s in common, but the one on the left has a 4, the one on the right has a P minus 3. So each of my rational expressions is going to need multiplied by something. Okay, let's see if I can move this all at once. Maybe. Hey, there we go. So I am going to multiply. Let's do it in red here. I'm going to multiply this one by what it's missing. And all it's missing is the 4. This one over here needs multiplied by the P minus 3. So let's rewrite this out because I have made a massive mess here. Okay, so the left one, okay, we're multiplying by P minus 3 in the numerator and denominator. So we would have 2P minus 6 all over, and remember I'm going to keep it in factored form, 4 times P minus 5 times P minus 3. Okay, we are adding these together. My right rational expression is getting multiplied by 4, so I would have 4P minus 26 all over 4 times P minus 5 times P minus 3. So now we can add them together. I'm going to actually add numbers correctly this time. So we would get 6P minus, let's see here, negative 32. So 6P minus 32 over 4 times P minus 5 times P minus 3. All right, so now we're in the spot where we want to factor our numerator so that we can cancel with some things in the denominator. And I just noticed I made another mistake. I am just on fire today. So this, as I'm sure you caught as I was going, because you guys catch me all the time when I make ridiculous mistakes like that. This is really a 4P minus 24. So that means this is really just a 30, which makes this a little bit easier for me. Okay, we can factor a 6 out. That leaves me with p minus 5 over 4 times p minus 5 times p minus 3. I can cancel out the p minus 5s. I can reduce the 6/4 to 3/2. So I end up with the final answer of 3 over 2 times p minus 3. All right, guys, sorry for all of the mistakes. I'm not sure what my brain is doing today. But if I made any other ridiculous mistakes, please feel free to correct me. I don't want anybody to get confused because I just can't do mental math today. So, hope this helps. Please let me know if you have questions and have a great day.